We're back on section 3.6 and this is a word problem example. A ladder is 20 feet long and rests against a vertical wall. Let theta be the angle between the top of the ladder and the wall. If the bottom of the ladder slides away from the wall so that the angle increases at a rate of 1 radian per second, how fast is the bottom of the ladder moving when theta is equal to pi third? It seems like a lot of variables are connected to each other, but rate of change is asked with respect to time. So I'm expecting some related rate problem in here. Let's draw a picture first. Let x be the distance from the base of the ladder to the wall. And this is what's happening. It's the ladder is 20 feet tall, long, and the angle it's making by the wall is theta. The distance from the end of the ladder to the wall is x. This looks like a triangle, a right triangle, because walls and the buildings are perpendicular to the floors or ground, basically. Now, so this is the right triangle. What we're trying to connect is this x, 20, and theta. According to the trig function that connects them is sine of theta equal to x divided by 20. So I can write x is equal to 20 sine theta. Now, if you take the derivative of both sides with respect to time, derivative of x with respect to time is going to be dx dt. And that is dx, this side, with respect to theta, the derivative of x with respect to theta times derivative of theta with respect to time. Derivative of x with respect to theta is 20 cosine theta. Derivative of d theta dt is already given in here, and it's 1 radian per second. When you multiply everything together, you get that dx dt is 10 feet per second. Right, look here, question 3. The equation of the line tangent to the graph y equal to 2 sine of 3x at x equal to pi third is A, y equal to 6x minus 2 pi. B, y equal to 6x cosine 3x minus 2 pi. C, y equal to negative x plus 2 pi. D, y is equal to negative 6x plus 2 pi minus 1. E, y equal to 2 pi. Pause the video and come back and solve it. So I hope you paused and know your solution to the question. It's the first thing is that it's asking for a tangent line. Therefore, I'm going to take the derivative of y with respect to x. Derivative of y. 2 is a constant coefficient. Derivative of sine is cosine, inside unchanged, times derivative of inside, which is 3. So the entire thing is going to be 6 cosine of 3x. Now, we're evaluating derivative at pi third. What is cosine of 3 pi third? Cosine of pi, and that is -1. So if I evaluate at pi third, the answer is going to be -6. So this is the slope of the tangent line. How do I find the tangent line itself? You need a point on the graph. So x equal to pi third is the x value for that point. Plug it back into here, and the y value for the point is going to be 0. So you're using point pi third and 0. So y minus 0 is equal to -6 x minus pi third. What is x minus pi third? Y is equal to -6 x minus 6 times negative pi third, which is plus 2 pi. And that's answer C. I click here question 4. The derivative of y is equal to secant of cosine of x. Is A, secant of cosine of x, B, negative sine of x, secant of x, tangent of x, cosine of x, C, negative sine of x, secant squared x, cosine of x, D, negative sine of x, secant of cosine of x, and tangent of cosine of x, E, 0. So if you haven't paused, pause and make sure that you know the answer or you solve the problem. Derivative of y with respect to x is going to be derivative of outside function, which is the secant of cosine of x. The secant part is the outside function. So the derivative of that, which is going to be secant of something, tangent of something, then derivative of inside, which is negative sine of x. What goes inside of secant and tangent is cosine of x. Unchanged. It's the inside function, unchanged. And answer is D,